Yes, it is the final set of sessions. I know there's another tea break, but that is not technically a tea break. It's tea and coffee after we're done. So, welcome to the final set of sessions for what has been, to so far, to me at least, an excellent PyConZA. I trust we've all been having a great time. We are going to kick off our lightning talks now. We have 30 minutes with 4 lightning talks that have been submitted. If you are not familiar with a lightning talk, as I've explained earlier, I'll just kind of give the basic details. A lightning talk is a 5-minute talk on something. Because we're a Python conference, we'd like it to be Pythonish, or at least technical. Or for that matter, in previous occasions, some people have submitted lightning talks about lightning. Or a literal lightning talk on the best way to use a post-it note and how to tear it off. And that turned out to be one of the more interesting lightning talks that we had. So it can be off the wall, it can be interesting. This year, our lightning talk presenters are slightly in luck. In previous years, everyone in the audience has been equipped with a rolled-up sock. And when time has extended, that sock has been flung at them. We've decided not to do that. But the way the lightning talks work, it's supposed to be 5 minutes. I will give you an indication when we're getting towards the end of the 5. We've got a little bit of flexibility, but not much. So we'll have to be quite tight on the timing. That's true. If after 5 minutes you applaud, the speaker must stop.
Yeah.
All right, I think that's everything there is to say about lightning talks. Are we good on... Yeah, no, it's up there. Perfect. Our first lightning talk today is Natu Lauchande, The Good, the Bad, and the Ugly of Writing a Technical Book. Natu.
Yeah. Hello, thank you, everyone. I just want to use my time quickly. So this is just like a brief reflection of my journey of writing a technical book called Machine Learning Engineering with MLflow. That was launched, I think, last year. And it all started in a PyConZA 2019, and I was presenting on MLflow and machine learning engineering back in, I think it was in Johannesburg. And then a few months later, I kind of received like a random LinkedIn message from someone from a publisher, technical publisher called Pact. Oh, we have seen your PyConZA video, and we don't see a lot of people writing or giving talks on MLflow, and it's quite a new piece of technology. Would you be keen to write a book? Like, obviously, I was over the moon, and I said yes. So, and then I'll go just to the journey, the good, the bad, and ugly, but these are just personal reflections to either inspire or uninspire you guys to write a technical book or do anything. Cool, the good. So yeah, after 10 months of hard work, I was able to, with this distributed team, to launch a book called Machine Learning Engineering with MLflow. Straight on the release, it was #1 in artificial intelligence. I will not specify for how much time it was, but because it's still the good. And look, I got, I ended up also creating a repo with all the code that I had in the book. The initial reviews were fantastic, great overview. There were videos raving about it. Obviously, I was over the moon, but things will go downhill from here. It's available on Amazon, and it's cool. And it was good, in the sense of I learned lots of things, but it was also based on kind of systematizing in my head, my experience of 5 years of implementing machine learning and data systems, because my title at the time was actually data engineer. It was quite an interesting technical challenge to put a lot of the things that I already had experienced in reading and going. So this is kind of how the book process works. You basically first have to send your idea for the book and your pitch. You need to pitch to a panel, how do you think this, and what is you need to have some kind of a narrative and some kind of a plan. It needs to look like a story, or so I had kind of 4 phases, problem framing, just conceptualizing machine learning in general, the basic stuff in all these ML projects, development and experimentation, how do you put it in production, and doing advanced topics on the technology. So I've used a bunch of technologies, because at the time MLflow was really very, it was not mature, and like things were changing all the time, and it actually didn't do all the things that it needed to do. So I had to use all of these other things to make to have a concise book and a concise narrative. This is the bad part. So it was really a lot of work. I think I got burned out multiple times during this process, and also the other big issue was that this tool that I wanted to write a book on was not very mature and was changing all the time. So when I was on chapter 10, I had to go back to chapter 1 and redo everything because things have changed it. So, and they initially I thought that the book would be done in Markdown. These publishers are really using very old technology. They forced me to use Microsoft Word. Was really bad. But during this 10 months, like it was really. Oh, okay. Okay, perfect. So yeah, this was when like the process was, I'd say, horrible, hard work. Needed to like write code, a lot of code as well, and yeah, but yeah, and this is the ugly part. I've showed you guys the initial comments that were very good, but this is like really like I had to go through many soul searchings after this, and I'll read louder just as part of my therapy process. Pretty bad, pretty piece of asterisk, asterisk, asterisk. I don't even know what this is. So, same good reviews at different sites, but the book is a shame publishing that. That was very painful. Poor writing. I don't know why the reviews so far are overwhelming positive. The book is a collection of something else, but like pretty bad. Like it reads more like, but this one was the one that affected me. It was not bad. It was not 1 star. It was 2 stars, which was cool. You can tell that the author seems to be knowledgeable. Oh, good. You can tell that he's more interested in showcasing the abilities of MLflow than really teaching how to create, for example, a workbench. You can tell that the author avoids explanations and sticks to simple sentence, pre-made meals. You can tell that the author also seems to be a bit lazy when it comes to help the reader. Yes, I'm lazy. Thank you. Yeah. So, and apart from that, the other ugly part is that it seems that after writing the book, like the real nightmare starts, because I had a repo here, and I think I had a meme for that. No, where's, oh, it's here. So I actually, because I'm mostly a data engineer and I do some machine learning engineering, I just tested most of the code in my MacBook, and for some reason the editors that pack didn't identify it. But I realized that basically most of the data scientists, for some reason, worldwide use Windows, and like I got this 20 like GitHub issues and complaints about it, and like was like ongoing support. Yeah, and yeah, from 5 stars in the initial months, and also like MLflow also changed very rapidly. It's a very different beast from what it was like when I wrote the book, and things are not compatible and they don't look the same, and people are still complaining. So it's currently at 3.3 out. Obviously in the beginning was quite cool, it was 5 stars, but this is, yeah, and a quick shot my journey. And do I recommend writing a book? I don't know. Like, cool. That's a no.
For those who didn't catch, thanks. Thank you, Natu. For those who didn't catch, the question from the floor was, would you do it again? And the comprehensive answer was no. Thank you very much, Natu. Our next lightning talk is Johan Beyers, Scoring Big Air, building a scoring system for the Red Bull King of the Air kitesurfing competition. I know what all those words are individually. Yeah, you might need that.
That works. Nice. Right. Windows, it needs to recognize my face. There we go. There we go. All right. right.
Fantastic. 5 minutes is starting, if that's fair.
Right. So, once a year, Red Bull invites 18 riders, 18 of the best kite surfers in the world, to Kite Beach in Bloberg for an event that lasts about 2 days. They have a 2-week time window because they have to wait for the wind. They only start this thing when the wind is predicted to be above 60 kilometers an hour. Scoring. Scoring on this thing, you have a 3-rider heat. They compete for 8 minutes. Then the judges deliberate for a minute. One of the riders gets flagged out, and they have another 4 minutes for the other riders to actually impress the judges again. Each trick is scored by each one of the 5 judges, and the trick is also described pretty fully. At the end of the heat, there's an overall impression score, and we've got a 3-minute time window between heats, or as I call it, my deployment window. This is what it looks like on the live scoring website. You'll see Yannick won, Val got eliminated, and you can see their individual scores for all the tricks listed, total score, impression score, all of that. I did not design the screen. I did design the feeds that provide the data there. Right, this is what it looks from the judges' tower. You can see the judges. They all have an iPad in front of them. And another shot with the trick callers on the side closest to me. At the back is the head judge, and then the technical team, including my empty seat, right at the left. So we've got information that needs to be coordinated over all those things. There has to be a live timer on all the judges' screens so that they can see how much time's left. As the trick caller puts in the information on the trick, the judges need to see the updated information so that they're sure that they're actually scoring the correct trick. This is a bigger problem than you would have thought. Once the score is confirmed, the technical team looks at the scores, sees that the judges are all kind of in agreement, and only then is that score locked and visible on the website. We don't want half scores being shown to the people. That's the data models. Don't have time. The software stack. So I'm using PostgreSQL, Django REST framework, Vue for the front ends, jQuery for the Ajax calls. Don't ask me why, because I knew jQuery and I could copy and paste a piece of code that I had already. And then Bootstrap with 3 lines of custom CSS. That was the extent of my front end work on this. The general rule in high volume systems is don't poll. That went out the window. Each one of those machines, each one of those iPads polls every 4 seconds. And then I've got a Django admin with inlines for the tech team. And I will hopefully show you that in a few slides. On site, we've got 2 Ubuntu laptops. That's our redundancy. We've got Ansible configuration from bare metal on those laptops. We have fixtures to pre-populate the competition. All the riders, all their details, everything like that. And then for deployment, I've got a script to pull from the repo, run collect static, and restart all the Django workers. The feeds that we needed to provide. We've got a local XML feed that is fetched from the video transmission that they use for the subtitles. Then we've got a shell script that just rsyncs every few seconds to for the live scoring that does the website, and also a push JSON script. Failover, we DB dump every minute, and then we can restore it on the other machine if needed. So that's what the other screens look like. I've got 15 seconds left. This is what went wrong. If you want me to go over, I will. Otherwise, talk to me afterwards. This was a great project. We designed it, I designed it to the constraints. Simple thing is best, charge more. I charged for 120 hours, did it in 160. Do things, tell people. In other words, talk at PyCon. If you want to see anything else about me, johan.beyers.co.za. That's me.
Perfect. Thank you, Johan. I
Alright.
think time, as time stands, if you want more details from Johan, I'm sure you'll be around at least for a little while to catch more details about the things that didn't work. But we'll be on the positive aspect that clearly it worked enough that it was great. So thank you, Johan. Our next lightning talk is the other van der Merwe, Steven van der Merwe, from Clean Code to Clean ML Models.
Testing, no. Is it on? Testing, testing. Yeah. Cool. There we go. All right.
Sorted. Thanks, Steven. It's great.
And let's see. Yeah. Testing, testing, testing. That fine? Yeah, cool. All right. Hey, afternoon, everyone. My name's Steven van der Merwe. I'm from Synap Labs here in Umhlanga. We're a hardware, software, technology company. We're trying to just really focus on building good technology for the automotive industry. And at the moment, we're focusing on driver safety. That's our website there. You can go check out our product that we're currently building over there. And today I'm going to focus on something that I'm very keen on is really what does it mean to just build clean software, and how does that translate to data science? Because that's something I haven't really been able to get my hands on properly. So if anyone's got any advice or wants to chat afterwards about what we're doing, please come chat. All right, cool. All right, so we're building a product that basically monitors the driver, detects if they're distracted on their phone, eating, or falling asleep. So that's the product. One of the key things that I do during code reviews is I focus on solid principles. You can check out Call Him Uncle Bob. Robert C. Martin. He's written a few good books on clean code, and he can take you through a lot more of these principles. Today I'm just focusing on the bottom one there. It's called the dependency inversion principle, and basically that means you're trying to focus on an interface instead of trying to work with various objects directly. And so by doing that, you really simplify boundaries between your different teams in the company and the services that they actually build. So what I really focus on is trying to decide, did I really want to have different models for each and every different task that we do? And the answer really was kind of, but not if we're going to have, let's say, 5 teams, they're each doing their own services, and basically one team might do face recognition, another team might do pose estimation, another team might do object detection. So you got all these teams working together. How do you actually put them together in a room and actually get them to decide on something? And really the decision was get them to build software as a service, get them to work through HTTP, and build a common layer between those teams. And so that product ended up being something called Nucleo, which is really, really cool in the data science world. This is pretty much like AWS Lambda or Azure Functions, but really focuses on building clean Docker-based images in the cloud as functions. So you'll get that software as a service with a clean interface. So you get to change your Python scripts that you build, and you get to turn them into Docker containers, so wrap those up. You can call them via browsers, Azure Event Hubs or Kafka, or you can call them directly from a browser or another service. So that really just changes what it means to communicate with another team and the products that they're building. Yeah, and that's it, really quick. So super, super quick. And the point being, and I know I would have skipped over a few things as I'm skipping over the cables and laptops over here, but basically the idea is stop trying to just build MR models and send them over Microsoft Teams and email them to your teammates. Focus on building clean services in the cloud that ship, that are in Git, that are really well controlled, and you'll actually build very good review processes when you're trying to work with your different teams. That's really where I am at. This was a small project we embarked on, and we're still on that journey, and we're trying to improve it as we go. So yeah, if anyone's got any questions or interested in what our practices are, happy to chat.
Perfect. Thanks, Stephen. And you're inside. You've got 1 minute left. So
Yeah, we're also hiring, so there's my last minute. Cool. Thank you.
sorted. Thank you very much, Stephen.
Cool.
Oh, well, take a question for a minute. We've got.
So Nucleo is another product. You can go check it out, nucleo.io. It's integrated into a few ML run one panel. There's quite a few open source data science products that are essentially packaged as a platform, but are quite a few products underneath them. Nucleo is just really good for. Yes, it does. Yeah, yeah. You can deploy it with Docker very, very easily. So it's like your own version of AWS Lambda, but instead of deploying a Docker container itself, you just have a YAML spec file. Tell it what image it is, and you can ship your Python just like that. Your data science team doesn't need to know about Docker. That's the other key.
Yeah, there's the takeaway.
Cool.
Perfect. Thank you. Thank you, Stephen.
All right. Thank you.
And our final lightning talk, and I see David's come to rescue his equipment, is COVID wastewater tracking by Colin Anthony.
Okay, that's better.
All right. Thank you, Colin.
Okay. So this is just a quick talk about mapping COVID cases to wastewater treatment plant catchment areas. And so a brief bit of context. Back when everybody was still very concerned about COVID, I know that the impetus has dropped off a lot since the severity of the hospitalizations has dropped away. But a couple of years ago, it was obviously front and center, and there were some issues. So tracking COVID cases wasn't homogeneous because there were different testing regimes that were rolled out. Different demographics were prioritized. Some people just weren't getting tested, and now we're at a position where testing data for COVID is highly unreliable because people just aren't. They're getting infected, but they just aren't going to get tested. And so, if you want an early advanced warning of COVID, one of the ways of achieving that is looking for evidence of the COVID virus in wastewater. So this is something there's actually an article I saw yesterday
where they've seen a spike in the COVID cases in wastewater in the Cape Town area, just in the previous 2. And the MRC is running this. They've actually got a dashboard up where they monitor this. But the work that we were doing was, we were wanting to sample this wastewater for the presence of COVID, so that we get an indicator of incidence. And so we wanted to calibrate that, because we can test how much virus is in the wastewater, but how do we know what value means something? So we can look at relative values, but how much is high, how much is low? So we wanted to correlate the values, the detection in the wastewater with the known cases that we actually had. And so this is what the wastewater catchment areas look like for the city of Cape Town. So the different colors are different catchment areas. So if you live in that area, your wastewater goes to one centralized plant. And the COVID case data that we were receiving from Provincial Health was geolocated to different levels of granularity. And that was from we had the health sub-district level, which is what you can see here. So it's obviously quite broad areas, as well as a couple of other areas, and also down to some quite fine resolution mapping. So this is the hexagonal, the H3 mapping system, and that was down to 5 or 1 square kilometer radius. And when you're wanting to go from cases to wastewater management, you need a fine resolution to map the cases across properly. And so one of the things, is that with the geocoding data, the finer the resolution is of your COVID data, the greater the level of data loss was. So it's easy to map something to, say, a main place, a stats main place, or a large area like this. You can easily get some part of the address and map it to somewhere in there. So maybe it's like just a suburb or something like that. But to get down to the finer resolution data, especially for certain areas of the city which are maybe less formal, you have a massive drop-off in the amount of data that you have. So you get a massive amount of data loss, and depending on the different level, you can see here you're getting up to 40% data loss down at the lower end of the resolution. And so when we then had to do the mapping, we needed to basically account for this data loss in some way. And there were a couple of complexities. So because that data loss is not proportionally distributed across all areas equally, some areas, especially areas with high levels of informality, those addresses often didn't translate very well. And so we got very low levels of fine level geocoding for them. So I won't go into too much details, but we had to do some manipulation of the data to adjust for that data loss and for the fact that there was disproportionate data loss in certain areas. So the next thing we did was, it's a fairly simple operation using GeoPandas, converting the polygons from the wastewater areas into the hexagonal format, which allows very easy mapping then from the COVID case data. And then wherever there's an overlap, we obviously we allow proportional assignment based on where there's overlaps. And there were some edge cases where we had to watch out for there, but I won't go into that. And essentially we can then roll that back up to see which are the wastewater treatment plants that are carrying the biggest load. And then we can look at that over time and correlate that to the actual sampling data from the wastewater treatment plants over time. And I can't present on that work because it's part of an ongoing study, but I would just like to acknowledge the various people in the city who were involved in the different parts of this work. Thank you.
Fantastic. Thank you, Colin. It's truly fascinating stuff. I had David has just suggested to me it is technically 3:30. Not 3:30 at all. We lost an hour. It's 2:30, and it would be time for the keynote. David has just suggested that it might be of interest to everyone if we can stream just a brief video to you that we took yesterday of exactly how all this stuff works. And the reason all this technical complex stuff works is because Adam is very, very good at it. And Adam is wisely ducked out of the room because he doesn't want to hear me praising him, but Adam is next door to taking things apart. So if you'll give us a couple of minutes indulgence, I think you'll find it interesting, and then we'll roll into the keynote. Okay. There's a lot of complexity going on here with the streaming and the remote and which screen goes on which squad and what you can see, and Adam's got it down pat, and he's really done a lot of great work at it. So.
Yeah, so Adam has said he's not proud of this setup, and it will get better, and join the sprints if you want to make it better, I suppose. But, so with any luck, we should be seeing video 3, 2, 1. We should be hearing audio. This was the briefing for the people who've been trying to set up the online streams and how it all works in OBS.
Okay.
I'm also rolling camera so that I can show someone else later.
Okay, cool. So the first thing you need to do is get the a URL from the speaker for the camera and a separate one for the screen. Usually one of those is going to have the sound as well. So there's the channel that they already know about called Stream Setup. Oh, by the way, each Stream PC has its own Discord account. So this is for example Stream PC 3, and then 2, and then 1. So they all have their own Discord accounts in case you need to like try to communicate, and they don't have much in the way of channels. So you'll see Stream Setup channel, and there are already some people posted inside it. So let's take the latest one. Wow, there's a whole bunch of them. They're posted really early. So let's say audio and camera. So I'm just going to right click this, copy the URL, and inside here you go to anywhere. So you're going to see that there's some places like these are different scenes basically. So like holding slide, the speaker camera only. They don't have a camera there right now. And then for example, like these different scenes. So if you want to mix like the speaker camera and screen, well hopefully we'll see them now. So what you're going to do is go to yeah?
I think you might have got the person, Elijah, I think it's the second talk of the session. Maybe go to that and look for one from Hart.
Okay. From Hart. Okay.
He's the first speaker.
So that was so speaker camera. So you see the sources are duplicated everywhere. So if you go somewhere else, you'll see like speaker screen and then speaker screen again. That's camera. So don't worry about the Blackmagic camera. The reason why the Blackmagic camera is inside here, even though you don't see it, is because we have problem inputting sound. So we have to do some stuff. So we're actually using the camera for input sound right now until we find ADC, like USB audio inputs. So you just double click on the speaker cam, and then you just put, when you just hear your existing URL, you just put a new one in, and it's okay. And if they have it set up correctly, it'll start appearing. And yeah, I don't know if it is. Okay. Then you do screen, copy the link. There we go. See, camera's on. So you go to screen. Do the same thing for the screen. Copy, paste. What the? Wrong one. Copy. Yeah, and okay. That should be the screen just now. Yeah. Yeah, I think the person's turning it on low. So yeah. Should. But it was on momentarily. Should probably show you with my laptop. And then that's all you need to do. Now, there's one. In order for now, you can actually speak verbally with the speaker. It's also more for the MCs. So there's this microphone. It doesn't have to be plugged in. It's wireless. And we did this thing where we're actually in the Discord channel, where they actually hear the input. So you can actually see it speaking right now. Actually, could be some echoing probably. Hello, testing. Let me just make it louder so you can hear. I'm connected right now, the other one louder so you can hear. Yeah. So I'm connected right now, the other one louder. Yeah. Okay. Yeah, okay. Hello, testing. It's echo because it's working. So so this is like what people are. So whenever it's red, it's muted. When it's not red, then it's muted. So if you want to talk to the speaker, or give it to the MC to talk to the speaker. I do the MC. Oh, okay, excellent. By the way, it has like a 6-hour battery life. So just to be safe, you can leave it plugged in over here. This is the micro USB. And of course it has long range. Okay, so now once it's set up, and this is the same for all the rooms, what you have to do is click on Manage Stream. Manage Broadcast, and then you'll go to select existing broadcast, and you'll see all the talks we have. So what's the talk called again? So we have a browser here, so we'll just open that browser up.
It's building and testing cloud application. Locally.
Oh, it's local stack, yes, yeah.
Yeah, okay, so we have the thing here, the building and testing cloud. So just don't be afraid to just open up the browser. Oh, by the way, if you want to open this, you have to, this is Papa West, so you have to move your mouse down, to bring to the bottom. Okay, so building and testing. Click that,
And
you
the stream's
select
about to go live.
broadcast and start the stream. As soon as you click that, you're all good. Neil, on the start, when you go to the YouTube streaming page, there's normally when you click start broadcast, you have to click again to actually go live. But I select it to automatically go live. We have to do it inside YouTube. I did it for all the videos. You have the auto go live button inside there. To make it easier for these guys.
Okay.
Yeah, so this is one thing.
Okay, yeah.
Cool. So that was basically the process of getting all the stream links together for that remote talk to be able to connect the remote speakers in, chat to them over Discord. It's pretty mind-blowing. There's lots going on there and lots of fun things to play with. And it's the first year we were using OBS, so I think Adam is probably not in the room and giving a talk at the same time. So that's an achievement all at the same. So let's give Adam a round of applause in his absence.
I should also note, while we're praising Adam, I was here with him on Wednesday. He arrived Wednesday. He's up from Joburg. I'm the local. We set everything up on Wednesday while the tutorials were going on. Come close to about 11:30 on Wednesday night, I finally said, look, sorry, I really have to go home. Adam assures me he'll be about another hour and so forth. When I got here on Thursday morning, Adam most clearly had not gone anywhere. He worked through Wednesday night to make sure this was ready for everybody. So brilliant dedication from the man. So. And having indulged us in a brief delay, it is now time for our keynote. JD?